Hello class. The next section we're going to be filling out in our intro to IM2 flipbook is section number 1, and this is the bottom flap of section number 1. In section number 1 we deal with distance, or how to calculate how far 2 points are apart, or the distance between those 2 points. And we're going to do it 3 different ways. I'm going to show you in this video how to determine the distance between 2 points that are on a graph. And then there'll be additional videos for figuring out the distance between 2 points without a graph. And then I have a shortcut method. Some of you may like to use that. It's faster and works pretty good, but you do have to memorize the actual procedure for the shortcut. So in this video we'll just look at distance with the graph. You can see I already filled out the title for you here. So if you would fill that out, distance with a graph. Before I continue, let's go over something real quick, because I've had students in the past get confused by this. If you're going to write this in the margin here on the left side of your flipbook page, distance equals length, exclamation point. When I talk about the distance between 2 points, we're also talking about the length. So look at the graph over here on the right side. If I asked you what is the distance between point A and B, that's the same thing as asking you what is the length of the segment that connects point A to point B. So when I use the word, or we use the word length, the length of a line segment, or the distance between the 2 endpoints of a line segment, we're asking you the exact same thing. How far apart are they? What is the measurement between those 2 points? So distance equals length. Alright, let's cover a simple thing here. If segment endpoints are directly vertical or horizontal, you just count the distance in units. And to cover that, let's take a look at this. Look over at the graph. If we have a point right here, point A, let's call that point C, since point A is already on here. And then I put a point D on here, and I ask you what the distance is between those 2 points. You don't have to do any math calculations, just count units. 1 unit, 2 units, 3, 4, 5, 6. Those 2 points are 6 units apart. And the same thing would apply if I was looking at 2 points that are exactly vertical from each other. So vertical meaning they're exactly on top of each other. Horizontal means they are exactly to the left or the right of each other. Same thing here. If I had a point and I called this point E and this point F, and I asked you on a homework or a test, what's the distance between point E and point F? You don't have to use distance formula or Pythagorean Theorem or anything else. All you need to do is count units. 1, 2, 3, 4. The distance between point E and F is 4 units. And over here we had what? 1, 2, 3, 4, 5, 6. So 6 units. 2, 3, 4, 5, 6. Make sure I got those right. So if the segment endpoints, or the points on the graph, are directly vertical of each other, up and down, or horizontal, left and right, all you have to do is count the units. Let's go ahead and erase all that stuff over there, and then we will continue. Okay, otherwise, so if we don't have points that are directly vertical or horizontal of each other, now we're going to have to use a different method. I want you to see in this case for this graph, point A and point B, you cannot, I repeat, you cannot do this. You can't say, okay, let's count 1, 2, 3. You can't do that, because the distance between these 2 points right here, that's not the same as the distance of 1 unit, or the length of 1 unit right here. When you go diagonal, now you can't use counting. You have to actually calculate the distance. So the first thing we'll do is you create a right triangle. You create a right triangle. And I'll be doing that in a moment. Let's just go through the steps of how to figure out distance with the graph. first create a right triangle. Next thing we do is you find the lengths of the two legs. So you're going to be seeing, we're going to be doing something like this. I'm going to create a right triangle right here. There's one leg. There's the other leg. We're going to figure out what the length of this leg is. It's easy. All we do is count. We're going to figure out the length of this leg. It's easy. All we do is count. Let's get rid of those a second. Okay, step 3. We're going to use the Pythagorean Theorem to calculate the length of the hypotenuse. And if you look at this diagram in a moment, you're going to see when we create a right triangle, that's a terrible line there, but just bear with me as I try to draw straight lines for you guys. As you make a right triangle here, the hypotenuse, which is this side right here, that's the length or the distance we're trying to figure out. So if we can figure out this leg, and we use Pythagorean Theorem, we can actually calculate the distance or the length of segment AB, or the distance between points A and point B. Let's get rid of those. Okay, so use the Pythagorean Theorem to calculate the length of the hypotenuse, which is the segment we are finding the length of, and then last step is simplify the answer or convert it to a decimal. Okay, you will find in this case you will always end up with a square root answer, and you'll need to simplify that or convert it to a decimal. All right, well, let's go through our example here on the right side of the page now. What is the length of segment AB? And it's telling us the units are in miles. Units are in miles. That means once we figure out how many units there are between points A and point B, then we're going to convert that to miles, or say that that is equivalent to miles. And again, just to clarify, when it says units are in miles, that means, class, that this distance right here, this side of this square, is 1 mile. Likewise, this segment right here is 1 mile. Okay. So, Pythagorean Theorem. We're going to pull this out of our memory from previous classes. Pythagorean Theorem is just a squared plus b squared equals c squared. This is a known theorem discovered by a previous mathematician, and it only works for right triangles. So let's take a little note here. This is right triangles. That's a triangle. Right triangles only. It only works for right triangles. Well, the cool part is, when we use this method of figuring out the distance or the length of a segment with a graph, we'll always be creating right triangles. All right, let's create a right triangle. I'm going to go ahead and try to draw a little better lines here if I can. So I'm going to go ahead and draw a vertical line here down from point A. I'm going to draw a horizontal line from point B. And you're going to see here, by doing that, I actually created a right triangle. There's a right angle right there. And now we can use Pythagorean Theorem. Let's figure out the length of this leg. It's 1, 2, 3, 4, 5. So this leg right here is 5 units long. This leg here from B to this corner is 1, 2, 3, 4, 5, 6. This leg is 6 units long. And now, remembering Pythagorean Theorem, we can pick the two legs can be labeled either A or B. It doesn't make a difference which one we label. Let's just go ahead and say that this one is going to be A. Oop, I'm going to change the color there so you can see that a little bit better. This one is going to be A. And I'm going to use this number as B. And then remember, the hypotenuse is always C. The longest side, or the side that's directly opposite of the right angle, is always the hypotenuse, which is C. Let's go ahead and rewrite our equation and plug in what we know. We know that A is 5. It's going to be 5 squared. Plus B is 6. That's going to be 6 squared. Equals our unknown hypotenuse, which is C squared. Okay, next step, let's go ahead and square these numbers. So 5 squared, you can use your calculator if you cannot do this in your head, but I know that 5 squared, or 5 times 5 is 25. 6 times 6, or 6 squared, is 36. And again, that's going to be our unknown hypotenuse, c squared. Next thing we'll do is add these two numbers together. 25 plus 36 is 61. So now we know that 61 is equal to the hypotenuse squared. But we don't want the hypotenuse squared. We just want the length of the hypotenuse, or the length of segment AB. And you've learned in previous math classes, and we've probably already covered this in class, when you want to get rid of a square, you're going to square root it. So I can mathematically square root the c squared, and when I square root one side of an equation, I have to also square root the other side, because we have to keep our equation in balance. The cool part is the square root cancels the square. So these two basically cancel each other out. A square root undoes a exponent of 2, or a square. So then we're just left with c on this side. So let's go ahead and wrap this up. This means, I'll just put an arrow here so you see, this means that c is equal to the square root of 61. The square root of 61. So we have figured out now what is the length of the segment AB. It is equal to the square root of 61. Now usually on a test or on a homework, I'm going to want you to convert this to decimal. Usually you'll see, like if I asked you, hey, how far is it from school to your house? You're not going to say the square root of 102. You're going to give me the approximate miles or some other measurement to tell me how far it is to your house. So let's go ahead and do this. If you plug the square root of 61 into your calculator, you're going to get a decimal answer, and we're going to have to round this answer. So the square root of 61 is approximately, here's our approximately symbol, is approximately, and if I round it to one decimal place, it's approximately 7.8. And now let's take a look. It's not 7.8 units, because we know the units in this case are in miles. So in this particular question, we're looking at 7.8 miles. So the distance here between point A and B, or the length of segment AB, is equal to 7.8 miles. Now you know in this class I'm going to want you to be writing a lot of your answers in sentences. So the way we would write this in a sentence, let me change the color here, is the length of segment AB, segment AB is 7.8 miles. Continue if you can, class, to get used to writing your answers in complete sentences. Alright, so that covers how to figure out the distance between 2 points when those 2 points are on a graph.